the analog modulation and the digital modulation. So if the message signal is analog, then it is known as the analog modulation, and similarly, if the message signal is in digital form or in terms of the ones and zeros, then it is known as the digital modulation. So first of all, let us talk about the analog modulation. So based on the type of the carrier signal, this analog modulation can be further classified into two categories, that is continuous wave modulation and the pulse modulation. So if the carrier signal is continuous wave signal like a sine wave signal, then it is known as the continuous wave modulation. On the other hand, if the carrier signal is a pulse signal, then it is known as the pulse modulation. And first of all, let us see the different types of continuous wave modulation. So mainly there are three types of modulation, that is amplitude modulation, the frequency modulation and the phase modulation. So in case of the amplitude modulation, the amplitude of the carrier wave changes according to the message signal. So if this is the message signal and the high frequency signal is the carrier signal, then the amplitude modulated wave would look like this. So as you can see over here, the shape of the carrier wave changes according to the message signal. Similarly, in case of the frequency modulation, the frequency of the carrier wave changes according to the message signal. So with the increase in the amplitude of the message signal, the frequency of the modulated signal will also increase. Similarly, with the reduction in the amplitude, the frequency of the modulated signal will also reduce. And similarly, in case of the phase modulation, the phase of the modulated signal changes according to the message signal. So in the upcoming videos, we will talk about all these different modulation techniques in detail. Alright, so now let us see the different types of pulse modulation techniques. So mainly there are four different types of modulation techniques, that is pulse amplitude modulation, the pulse width modulation, the pulse position modulation and the pulse code modulation. So let us briefly see all these techniques one by one. So in all these modulation techniques, the message signal is analog in nature while the carrier signal is a pulse train of the finite frequency. So in case of the pulse amplitude modulation, the width or the duration of the pulse will remain same, but the height or the amplitude of the pulse signal will change according to the message signal. Similarly, in case of the pulse width modulation, the height or the amplitude of the pulse will remain same, but the width of the pulse will change according to the message signal. So here, the message signal amplitude is sampled at the rising edge of each pulse, and the width of the modulated signal is proportional to the sampled amplitude. And in fact, on the pulse width modulation, I have already made the separate video earlier. So for more information, you can check that video. Similarly, in case of the pulse position modulation, the width and the amplitude of the pulse will remain fixed, but the position of the modulated signal will change according to the input signal. So at each rising edge, the message signal is sampled, and based on the amplitude of this input signal, the position of the modulated signal will change. That means as the amplitude of the input signal increases, then this modulated pulse will further go away from the reference position. And in fact, it can be generated with the help of the PWM signal. That means by generating the pulse at every falling edge of the PWM signal, this PPM signal can be generated. Alright, so now let's move to the next modulation scheme. So in the pulse code modulation, the message signal is sampled at the finite interval and the sampled value is quantized using the quantization process. And then using the analog to digital converter, the message signal is encoded. For example, if the sampled value is encoded in the 5 bits, then for every sampled value, we will get a pulse code of 5 bits. So this is the very brief overview of the pulse code modulation. But in the future videos, we will see in detail about this pulse code modulation. Alright, so far we have seen the different types of analog modulation techniques, where the message signal was in analog in nature. Similarly, let us briefly talk about some of the digital modulation techniques. So in a very broad sense, mainly there are three different techniques. That is amplitude shift keying, the phase shift keying and the frequency shift keying. So in all these digital modulation schemes, the message signal is in digital form. So this amplitude shift keying is a one form of digital amplitude modulation where the amplitude of the modulated signal changes according to the digital bit stream. So in this scheme, the binary signal 1 is represented by the fixed amplitude of the carrier wave, while the binary 0 is represented by the 0. Similarly, in case of the frequency shift keying, the frequency of the modulated signal changes according to the digital bit stream. So here, the binary 1 is represented by the 1 frequency, while the binary 0 is represented by the different frequency. And likewise, in case of the phase shift keying, the phase of the modulated signal is changed according to the digital bit stream. So in a binary phase shift keying, the binary 1 and 0 are represented by the different phases. And to be precise, they are 180 degree apart from each other. So when there is a transition from 1 to 0 in the message signal or from 0 to 1 in the message signal, then there is a 180 degree phase shift in the modulated signal. So that is the brief overview of the phase shift keying. So in a summary, we have seen that what is modulation, why it is used, and we have briefly seen the different types of modulation techniques. So in the future videos, we will see some of these modulation schemes in detail.